So for question 6, they give us this graph. We have these two functions, f of x and g of x. We have this vertical line here at x equals 2, this vertical line at x equals 5, and so we have these regions R and S. So f of x is x squared plus 2, g of x is x squared minus 2x. Now R is the region bounded by f, by g, by x equals 0, and x equals 2. We want to write but do not evaluate an integral expression that gives the area of the region R. So this is the area. Oops, let's use better size. There we go. Now it's going to go from 0 to 2, and it's going to be in terms of dx. And so what we do is each of these pieces are defined as f of x minus g of x. Now, this is probably not enough for College Board. You're probably going to have to write in for f of x, x squared plus 2 minus, and then in place of g of x, x squared minus 2x dx. And even further, we are probably going to have to simplify that. So we have x squared plus 2 minus x squared plus 2x. So the x squareds will cancel, and that will leave us with the integral from 0 to 2 of 2x plus 2 dx. And we don't have to evaluate this integral. All we have to do is write it. So that was part A. Part B, it says let S be the region bounded by the graph of G, the x-axis from x equals 2, and as shown here. Now region S is the base of a solid. At each x value, the cross-section that is perpendicular to the x-axis is a rectangle, and the height that's standing up is half its base. So we want to find the volume. So that's going to be 1/2 the integral from 2 to 5 of g of x, and that is quantity squared. Now the difficulty with this one is this integral we are going to have to evaluate. So we have x squared minus 2x, that is quantity squared dx. So that means we are going to have to expand that out. X to the 4th minus 4x cubed plus 4x squared dx. I'm not going to worry about the 1/2 for the moment. I'm just going to focus on this integral part right here. So I have to find the antiderivative of this. So this is x to the 5th over 5 minus x to the 4th plus 4/3 x cubed. And then we want that integral from 2 to 5. All right, so if I plug in 5, that's going to be 5 to the 5th over 5 minus 5 to the 4th plus 4/3 times 5 to the 3rd. And then if we plug in 2, that's 2 to the 5th over 5 minus 2 to the 4th plus 4/3 times 2 cubed. Now, if I focus on the purple right here, notice that this is the same as 5 to the 4th, and this is 5 to the 4th, and those are being subtracted, so those just cancel out. So that's nice. And then we have 4 over 3 times 125. So that's basically, I'm just doubling 125 twice. So that means we have 500 over 3 for this part in purple. Now in green, 2 to the 5th is 32 over 5. 2 to the 4th is 16. And then we have 4/3 times 8. So we have 32 over 5 minus 16 plus, if I multiply 8 times 4, we get 32 over 3. Now, what we need to do is we need to get a common denominator here. So, for 32 over 5, that's going to be 96 over 15. I'm going to leave 16 alone. I'm going to come back to that. And then for 32 I'm going to have to multiply. That's times 3. 32 over 5, we're going to multiply 5, top and bottom. And so that is 160 over 15. So we put those two fractions together. We get 256 over 15. So now, for 16, we're going to have to multiply by 15 over 15. So when I multiply that, I get 80 and 16, so that's 240. So we have 256 over 15 minus 240 over 15. So that is 16 over 15. So now we have to put them together. So 500 over 3 minus 16 over 15. So since I need a common denominator, multiply the first fraction by 5. So that's 2500 over 15 minus 16 over 15. And that gives us 2484 over 15. Now, one thing to notice, it doesn't end in a 5, so it's not divisible by 5. But if you add up 2, 4, 8, and 14, well, 2 and 4 make 6, plus 8 is 14, plus 4 more is 18. 18 is divisible by 3. So that means we can cancel a 3 out of this. And when we do, we get 828 all over 5. Now, we're not done, because, don't forget, there was still that 1/2 still in front of our integral to begin with. So that means for our final answer, so we have to take this number and multiply by 1/2. And since it can be canceled, so we have 414 over 5. And they don't give units here for this, so it's just 414 over 5 as our volume. Now on to part C. Here it says, write but do not evaluate an integral expression that gives the volume of the solid generated when the region S is rotated about the horizontal line y equals 20. Now that line is way up here. So that means what we have is we have the big radius from the center to the outer edge, and then we have the little radius. So that means our integral is going to be a washer. So we go from 2 to 5, and so it's big R squared minus little r squared dx. Now, to figure out the length, here we take top minus bottom, so this is 20 minus 0. So this is 20 squared minus, and then here this is 20 minus g of x. Now, we will see when the scoring guidelines comes out if this will be acceptable or not. So, but they say you do not have to evaluate it. Now, my guess is you probably have to substitute in x squared minus 2x in for g of x. That's just my guess. Could be wrong. And you probably have to square 20. Maybe, maybe not. So we have 20 minus x squared plus 2x quantity squared dx. All right. Thanks for watching. Check out the playlist if you would like to see any other problems from this test.